Hello students, good morning. Today we are going to start our lecture number 3rd of module 2nd. Okay, up to the previous lecture we studied McLeod gauge, Perrine gauge. Okay, now in today's lecture we are going to start our next point which is nothing but ionization gauge. Okay, see See, ionization gauges, the most convenient method of measuring pressures below about zero point 0.1 Pascal is to ionize the remaining gas molecules and collects the ions and measure the ion currents. Means in this ionization gauges, we are going to do that. First we are ionizing the gas molecules, and after that we are going to collect that discharge current or that ions current, and up corresponding to that ions current we are measuring the corresponding pressure. Okay, as we know, first of all, what is ionization? When we are giving any current or any electric supply to that molecules, then there is a that electrons removing the that electrons ionize the gas molecules, means there is a creation of ions, positive ions and electron pairs. Okay, see here in that ionization gauges there are the two methods. First one is a cold cathode, second one is a hot cathode. Okay, in that cold cathode there is a penning gauge and inverted magnetron gauge, whereas in hot cathode there is a Baird Albert gauge, it is also called as BA gauge, and extractor gauge. Okay, now first one, the cold cathode ionization gauge, an important class of gauge in the medium to high vacuum ranges, is based on a cold gas discharge in crossed electric and magnetic field. Means in this cold cathode gauges we are going to use electric field as well as magnetic field. Okay, and using that electric and magnetic field we are finding the discharge current, and after that we are finding the corresponding pressure to that current. Okay, now first here, see here, in such discharges free electrons are accelerated by the electric field and are trapped by the magnetic field, so that they have very long paths, much longer dimension than the gauge dimension. Means what is actually happening in this, as electrons as electron and ion sphere is created there, that electrons are accelerated by given electric field, as we are providing their electric and magnetic field, that created electron and ion pair in that electron are accelerated by electric field, and after that that electron are trapped by the magnetic field. Due to of that, what happened, that electrons are continuously moving in that helical path in that chamber. Means that electron acquired maximum dimension or maximum length in that space which are available there than the gauge dimensions. Due to that magnetic field, that electron goes in that helical path. Okay, and due to of that electron have maximum dimension as compared to gauge dimension. This means that even at low pressure, these electrons have a good chance of ionizing a gas molecule. This is very important point, because as we see in the first point that there is a presence of electric field as well as magnetic field. Due to of that magnetic field, what happen, that electrons are go longer in that helical path. Okay, and as they are go longer in that helical path, means they are able to ionize the maximum gas molecules, because as the path is longer of that electrons, they are go longer in that gas molecules and they are able to ionize the maximum gas molecules. Means as this is a cold cathode, means as there is a very low temperature, then also there is a maximum probability of ionizing that gas molecules due to of there is a presence of electric as well as magnetic field. Okay students, now many configurations are possible for such gauges, which are often referred to as fanning gauges, since the most popular configuration are based on fanning discharge. Obviously, see here, many configuration are possible for such gauges, which are often referred to as fanning gauges, since the most popular configuration are based on the fanning gauge. Yes, as this is, if that electrons are going to ionize the maximum gases, then this configuration are possible for mean such a gauges, which are of referred to as an fanning gauge. Okay, see here fanning gauge. In 1936, Penning invented the cold cathode discharge gauge as a method to measure pressure below 10 to the power minus 3. Means where that Penning gauge is invented, that Penning gauge is invented in 1936. Okay, see here, and that Penning gauge are used to measure the pressure below than 10 to the power minus 3 torr. As I studied, the McLeod gauge are used to measure the pressure less than 10 to the power minus 6 torr, whereas Pirani gauge is for 1 into 10 to the power minus 5 torr. Okay, and this today's is 10 to the power minus 3 torr. See here, in a Crookes tube below 10 to the power minus 3 torr, little ionization takes place. Pinning increases the probability of ionization by placing a magnetic field parallel to the path of ions and electron, which forces both the particles into helical trajectory. As I explained before, here there is a diagrammatically explanation. As these are the electrons which are come out from that filament, then and M is nothing but the gas molecules. Okay, M is nothing but the gas molecules. Okay, this M is nothing but the gas molecule, and M plus is ionized the gas molecules, ionized gas molecules, and this red wire is our collector. Okay, and that sided p dot dot line is our nothing but the green, which is at the positive with respect to filament. As you know, filament emits electrons. Okay, and that emitted electron, as this is grid, that electron obviously grid is at high potential. Okay, then our grid is also called as an anode. Okay, that emitted electron are attracted to this grid. Okay, due to of that high positive potential, and that electron comes towards the grid. Okay, but as there is a magnetic field is there, so here north and south, means bef- at the outer side of this there is a magnetic field is also there. First one, as the grid is at positive potential, that emitted electron move toward that grid with high or accelerated towards that grid due to the high potential, and after that acceleration, that coming electron first of all ionize, there is ionized the gas molecule which is here present here. Okay, and after that ionizing this gas, if this is a collector. Okay, then that if this collector is at negative, means the positive ions are goes towards this collector. Okay, attract, but what is about electrons are going in that helical path due to of that magnetic field. Okay, and that electron's trajectory is much more longer due to of that magnetic field, and due to of this that electrons are going to ionize maximum gas molecules in that chamber, and due to of that what happen, we can easily ionize the maximum gas molecules and pressure will be decreased, and that pressure will be measured by that gauge. See here, last one. This is a classic penning discharge configuration. It operates at fixed voltage and fixed magnetic field. Ions are collected on the ring anode. As I explained before, this is a graph, means as see here, as pressure is increasing, okay, current is also increasing. Okay, means from this we can easily conclude that when current is increased, when there is a maximum discharge is happening. Okay, when there is discharge is happening, as that emitted electron ionizing the maximum gas molecules, and there is a discharge of maximum that gas which is in that chamber. Okay, and from that from this figure we can easily understood that as pressure is increasing and current is also increasing. This current is nothing but the discharge current, means when that ions are collide with that collector, then there is a current. Yeah, measures pressure indirectly. Discharge current is used as a measure of pressure. Yes, the useful range of standard penning gauges is between 10 to the power minus 3 millibar to 10 to the power minus 8 millibar, or in special versions 10 to the power minus 9 millibar also. Okay, difficult to start and maintain the discharge between 10 to the power minus 6 star. Okay, this is the some advantage and some disadvantage of that gauge. Indicated value is the gas dependent, means this pressure value is, and this gauge is less stable and less accurate than the BA gauge. Okay, now in the next lecture we are going to study the hot cathode gauge. Okay, and in that BA gauge. Okay, thank you students.